Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast, a show about application, development, and management at scale. Thanks for joining us. Thanks to Cisco for sponsoring this episode of the New Stack Analysts. Cisco is an active participant in the cloud-native ecosystem and its development. Check out mantle.io, the open-source microservices framework developed by Cisco and the open-source community. That's mantle.io, MANTL.io. Hey, it's Alex Williams, the New Stack here. Pre-Thanksgiving podcast for the New Stack Analysts. We have a special show today. We have the editorial team from the New Stack here joining us with Joab Jackson, Lawrence Hecht, Ben Ball, and our special guest, Ken Owens of Cisco. Hey, Ken, how are you?
Great. Nice to meet with you guys again.
Yeah, we thought this would be a good opportunity to kind of think about where we've been in the past year and what's up for the year ahead, especially following the discussions that we had at KubeCon, with you on the pancake breakfast and in the other discussions we had there. And so I thought I'd kick it right off and ask Lawrence Hecht for some context here. I was just asking Lawrence beforehand, what does he see as kind of like one of the hallmark moments for the Kubernetes community, because it has grown so fast. And Lawrence has some pretty strong perspective. So Lawrence, you were talking about that point in the year when we saw the Kubernetes community really grow. What was that point?
I would say towards the end of last year in 2015, the amount of contributions and commits going to the Kubernetes projects kept on rising a lot. And basically, when I was looking at some of my stats, looking at meetup contributions and GitHub contributions, basically there was an intersection where Docker was having steady growth, nothing great, and Kubernetes intersected and kept on surpassing it. That was the tipping point. Let's say approximately November last year, and it's kept on growing. And all throughout this year, I get to see people posting charts saying that Kubernetes is the most popular project ever, or at least now, and it's and so it's keeping on growing a lot. The exponential growth is not there anymore, but it's still significantly growing in terms of number of contributors, the number of companies contributing, and the number of jobs outstanding for people with Kubernetes skills.
But yeah, but what you're saying too, it doesn't really tell the whole story though, right? I mean, that the code base is, in comparison of, Kubernetes, for example, to Docker are much different.
Yeah, so basically it's about, I'll say at least 10 times larger, the code base for Kubernetes in terms of lines of code. And so it requires more people to work on the code. So yes, Docker doesn't have as many people doing commits, but it doesn't need it. It's much simpler. And so that every time you do a large upgrade of Kubernetes, it's going to require a lot of extra work. So that's something to keep in mind, is that it's a much more complex system piece to start off from Google, and it has a lot of enterprise needs that it tries to take care of all at the same time.
So Ken,
what is the relationship between the number of contributors and the number of users? Well, what sort of conclusions can you draw from that?
What I draw from it is that when the contributions are coming from third-party companies, so in this case, not Google and not Red Hat, who have developed put a lot of specific engineering resources behind creating the guts of it. When you have contributions coming from people who are trying to create integrations and to build products on top of Kubernetes, that's when you can tell there's a lot of users. So that even though still 64% of all contributions are coming from Red Hat and GitHub, you're starting to see more contributions from Prenda, from Canonical, from a lot of the small vendors that are building upon it. So if they're making commits for integrations, then they're actually using the product. If there's a lot of commits to the core base, that means nothing. That just means that people are making it from going from 1.3 to 1.4, from 1.4 to 1.5.
Ken, any thoughts on that? I mean, there's so many different dynamics here, and one of them is the actual contributor base. And you've actually been involved in multiple different communities. What is your context about that point in the Kubernetes growth? And what are I guess thinking about what Lawrence is saying, in his in that initial spike last year and going forward. What are some of the kind of comparisons and contrasts that you saw that were insightful for you?
I think for a lot of what Lawrence was saying, I completely agree. There's a couple of things that are really interesting when you kind of dig into the details. Every year, you see these in January, you see all these lists of these predictions for the year, right? And so at the end of 2015, I kind of made a prediction for 2016 that this would be the year that we see containers in production. And the reason that happened, the reason why we're seeing a lot of this production deployment today, I can get into more of the details on the use cases, which is sort of the container as a service use case and kind of the rapid development and then providing a faster on-ramp to getting your application to production are sort of the two main drivers. But to the point that Lawrence was making, the contributions to Kubernetes, the growth of the Kubernetes community for orchestration and scheduling of these workloads, which is really key as you're trying to make this move towards a microservices architecture. And from a CNCF standpoint, right, one of the things that we on the technical committee look for when we're accepting projects, I should say, into the community is, are there any production use cases, or is anyone using this in production? And with Kubernetes, there was tons of production examples that we looked at. And I think that tells you two things, right? One is that it's, in addition to the contributions being spread out across multiple different organizations and communities of interest, which is true with Kubernetes, you also have rapid adoption in the enterprise space with companies deploying Kubernetes in production to run their production workloads, which has happened in a tremendously faster pace than even cloud adoption happened, right? So we're seeing sort of Moore's law coming into effect very quickly now. As new technologies are introduced, they're getting adopted much quicker into the enterprise space. And that comes up to my third point I was going to make, which is open source is really at the center of what's happening in this software transformation that enterprises are doing and undertaking, right? So it's none of this is happening because it's a core technology or it's fun to play with containers, right? All of this is happening because there's a real business need to transform the way they develop their applications to be much more agile and much more quicker to the enterprise changes that are happening in real time and being more disruptive and more innovative. And that requires open source. So open source is really a huge new kind of factor today in the enterprise software development lifecycle as never before. And I think you can, if you look back to the early days of Linux was really more about being, software cheaper for your operating system, right? Had really nothing to help the developers. And today, developers are really transforming the way they develop because of things like Kubernetes and Console and Vagrant and all these new tools that are in the open source community that are really helping them get their jobs done much more efficiently.
Hey, Ken, it's Lawrence again. I have a question for you. So when a lot of people were looking at the Kubernetes users, they're looking at cluster operators, application operators, and application developers. I have a theory that the application developers are not necessarily Kubernetes users, and that Kubernetes is made for the cluster operators and the cluster application operators. But you were still saying Kubernetes is really important for developers. Can you explain why that is, if maybe they're not actually the primary users of Kubernetes?
Yeah, so I kind of have looked at this from, there's two different use cases for sure. So you definitely have what I like to call the, kind of the infrastructure operators or the infrastructure DevOps team that are kind of creating the clusters and managing the clusters for the developers. So that's probably primarily the number one use case for Kubernetes is in that, and those cluster operators like you're describing them as. The second use case is sort of tied very closely to that because as the developers are looking at their application architecture, things like service discovery and scheduling, all of these different components that a developer has to think about for their applications to work correctly, they have to think about what they're going to do for these now. And if they didn't have those Kubernetes clusters in place, they couldn't do some of the scheduling and the orchestration that they need to do on top of that environment. And so for me, they're doing more application composition and service integration than they are managing Kubernetes clusters, but they understand what's below the covers, and they enjoy, calling into the Kubernetes cluster to configure certain parameters to enhance their applications.
Ken, good morning. Scott Fulton.
Hey, Scott.
A couple of weeks ago at KubeCon, you gave a talk, and behind you was a slide depicting our wonderful incoming president-elect. And the statement that the meme had him saying was, "We need to build a wall. VMware is going to pay for it." Now,
what does that mean?
The theme at that point of your talk was, let's stop building walls.
Right. Let's not do this.
What did you mean?
Yeah. So I meant two things. One is working as a community, adopting best practices around open source. I think is really important. I poke fun at VMware. I'm a VMware fan, and I don't hate VMware or anything, but I think the old regime of VMware, and to some extent even Red Hat, if you think about how Red Hat sort of prices their software, if you're into this buying product software and buying off-the-shelf software, you sort of get locked into a walled garden, right? With these services will work with these other components. If you go outside of this, validated design, or go outside of what we certified as being something we'll support, you're on your own, right? So for me, I think we need to sort of break down those walls, not get rid of the companies, right? Because I think VMware and Red Hat are going to be around for a long time, but I think we need to adopt this open source mantra and open source community and build that out in a way that doesn't have as many walls. There's still going to be walls, obviously, and some enterprises and some government agencies like to have these constraints around how they deploy software because it provides, something that they can kind of say, this is our best practice, this is our governance models built around this, and we need these controls in place, which there's nothing wrong with that. But I think that the first point I was trying to make is let's not start off the cloud native effort and say that you have to only use Kubernetes, you have to only use, Mesos, you have to only use Docker, right? We're not about picking winners in the cloud native foundation, right? We're about picking projects that sort of have these cloud native capabilities. And our goal is to have a lot of different ones available for consumers to choose from that are interoperable and do work together. We're kind of taking the IETF mantra of interoperability and showing two interoperable solutions working together. But if you kind of look at the community right now, you're kind of split between the Kubernetes community and the Mesos community and the Docker community. And I think we want to try to bring those three communities a little bit more together and have them interoperate closer with each other than to be three separate communities.
So where is your unified sphere of influence that you've just described, where all the communities effectively come together in relation to the architectural chart known as Cisco application-centric infrastructure?
Correct. So we have a couple of different layers, right? When you think about this in general, first I'll answer that, and then specifically to Cisco. I think from a couple of control points around OCI and the CNCF will help sort of, I'm not going to define standards, but I think we're trying to sort of provide a level playing field for everyone to kind of come and interoperate and see how the different solutions work, including, vendor solutions will be welcome into that community as well. And then as you look at specific companies, whether it's, it's Cisco or whether it's another vendor like VMware or Red Hat, I think what you have are these different layers. And so if you think about the cloud native reference architecture, you have that infrastructure layer that is where a lot of, public cloud and private cloud software was sit. That's where things like ACI from Cisco was sit inside the networking within the data center walls itself, right? Because as I like to explain to some of my friends that don't understand cloud, you still have routing and switches and servers in the cloud. They're just not yours, right? Cloud just means somebody else's infrastructure, but you still have infrastructure. And so that's where a lot of the networking components will sit in that bottom layer. Above that layer, we sort of have like the provisioning component, which is really more of those DevOps tools you think about. And that's where things like the APIC controller would sit in Cisco's world. That's sort of helping to provision all the networking components that sit in that physical layer below. Above that is where you have the runtime, which is where the Docker engine and some of the other software abstraction layers or software-defined networking, software-defined storage, all of the software-defined runtimes would kind of sit. And then above that is where you have Kubernetes sort of orchestrating and scheduling onto those different workloads onto those different runtimes.
So the community you're discussing has its own layer.
I think it's sort of a combination of community plus reference architecture. So it's that orchestration layer, that composition layer sits probably in the provisioning layer of the cloud native reference architecture. If you want to say what layer does it sit in, I'd say the provisioning. But you have to realize that there's northbound and southbound capabilities out of that layer. So,
now, given that many Kubernetes proponents are arguing in favor of a model where Kubernetes also is the orchestrator of the underlying infrastructure, how is that layer you've just described not separated by something called a wall?
Right. Yeah, so I think the easiest way to address that is to ensure that you don't allow any one technology or any one vendor or any one project to sort of say, I would not work with anything else, right? And that's really the only way to ensure that it's open, because you're right, within that orchestration layer, I should be able to provision an application directly into the public cloud and not talk to any other services, right?
Is this kind of some context for what we're hearing from the Cloud Foundry Foundation in terms of service brokers?
Right. Yeah, I think there's definitely going to be there's a lot of discussion we're having with the Cloud Foundry Foundation around service brokers and how they interoperate in this model, right? To date, I think a lot of the service brokers have sort of an opinionated view of how they service broker. And I think in some cases it's fine to have that opinionated view. In other cases, you need to be able to interoperate with things like Kubernetes and things like, let's say you're going to leverage, Calico or Flannel for your networking layer. You have to be able to embed these integration points into that service layer easily without forcing, like CNI down your throats, right?
Right.
Cloud networking interface down everyone's throats.
You mentioned CNI, Ken, and this has been, and we've obviously talked a lot about the networking components in our look on networking security and storage. And you were just kind of talking about the growth, I guess, of networking practices with containers and specifically with Kubernetes. Is that something where there's a relationship between certain themes or certain areas of focus where growth in networking these technologies is going to help people start to adopt, say, Kubernetes as an orchestrator more, or adopt greater usage of containers in different areas. Basically wanting to see if the whole focus grows at once or if there's kind of components that have to grow before others start to get picked up.
Right. Yeah, I think in general, I would say there's absolutely going to be a lot of changes in this area, because as you look at any technology that you're adopting, when you first deploy, Docker, when you first deploy Kubernetes, it's all working great and fine, right? Everything works great until it doesn't, right? Until you have a problem, until you have, a link go down somewhere, until you have some kind of a network failure or a compute failure, right? And then all hell breaks loose, and these projects don't self-heal themselves, right? And so as you go to production and start deploying these things in production, you need more enhanced capabilities at the networking layer and the security layer. I don't think it's really new networking or new security. I think the best practices of physical networking and physical security that are carried over to virtualized solutions in a cloud can be containerized in a cloud native topology, right? So I think the capabilities will migrate and will enhance over time, and that's when I think you'll see the growth in the space. Is when you see things like, Calico is a good example. At Cisco, we have Contiv that has been a good example of sort of bringing policy management and better control plane separation from the data plane that most solutions don't have. Like Kubernetes doesn't separate control and data plane on the network. So if you start having a flood of traffic, you're screwed. And so, to separate the control plane from the data plane logically is really important. And we learned that lesson 20 years ago. I don't know why we forgot all of a sudden, but, people who understand how to do the right application architecture are going to know that they need that separation. They're going to need to separate, and they're going to need namespaces that make sense so that they can figure out what broke when something broke, right?
And for us young people, what lesson was learned 20 years ago and how?
So 20 years ago, we learned that if you have a flat VLAN and you try to put all of your network data traffic, so communication for customers, your user traffic and your control traffic on the same network, you could have a flood of traffic that would then cause your control plane to break down and your user data traffic to not get from point A to point B. And you couldn't get in to figure out what was wrong because your control plane is down, because you took it down with all the data traffic. All your data traffic doesn't get anywhere because there's nowhere to go because the control plane was gone. And so it has nowhere to route the traffic. If it gets how to route because the control plane again is down. And so this is a lesson that we learned a long time ago, that flat networks with no separation and no control plane and user plane separation is just a dumb idea. And we seem to have forgotten that by trying to embed control and routing into the user plane again, which is just ludicrous, right? No matter how much bandwidth you have, it's not going to be enough, right? We've proven that in the OC 192 networks of the internet, right? And so if you think you have enough bandwidth, you're fooling yourself. And like I said, most of us will work on your laptop fine, right? And when you're doing everything on your laptop, you have no worries. But when you're trying to connect service A to service B and you have a physical environment to go across, something can go wrong and something will go wrong eventually in that physical environment. And when it does, you don't want your entire data plane and user plane to go down and your control plane to go down because you didn't architect your infrastructure correctly.
Good. So, Joab, any questions that you have on your side from looking at the year and and the perspectives that you've drawn in terms of your own coverage of the Docker and Kubernetes ecosystems and container ecosystems?
What I've been finding interesting of late is how the big traditional IT systems providers and the integrators have been slowly coming to adopt Docker, and at least Docker itself and the container paradigm as a whole. I'm talking about the most recent Oracle Open World containers had played a pronounced part. And last week I was at the Microsoft Connect conference, and they basically carved out a path for developers to use containers to house their .NET applications and to have them seamlessly work on the cloud, either Azure or private Windows Server based infrastructure as well. And so one of the things I'm kind of curious about, I'll throw this question out to our panelists, is what's the difference here? What's the difference from like a year ago when companies, when they wanted to set up a containerized based infrastructure, work primarily with Docker itself. Now they're going to Microsoft, Oracle. Next week we're going to hear more from Amazon. But how does that shift the landscape? How are the needs different with the large enterprise customers? How does the sales pitch change on some of these startups offering Kubernetes? Maybe I'll direct that to Ken at first.
Yeah, I'll take it. I'll tackle it first. There's a couple of really interesting points there I wanted to bring out. So I think one is I've noticed the exact same thing, right? That the adoption curve of this new technology is extremely steep. And what we've discovered in our use cases with customers is that the top issues we run into have to do with first monitoring, because it's the visibility of what's happening is not as strong as it needs to be. The second piece then is the integration of this is complicated, because it's, even if you were to buy a single solution from a single vendor, you still have to integrate all these piece parts together. Nothing really comes out of the box fully integrated, fully managed, fully monitored, right? So I think that's why you're seeing a lot of the systems integrators and what Cisco calls our channel partners, right? The ones that are working with enterprise customers very closely. You're seeing them adopt this new technology very quickly because, for one, it's not super easy to provision and manage and maintain and do day two with this as it needs to be. The second piece to your question, I think there's an interesting piece that I've looked and spent a lot of time thinking about with customers is, how do we make this more of a automated service defined environment versus the very labor intensive configuration model that it is today. And I think that's the second piece of this, that as this occurs, right, as you look at some of the tools like Kubernetes and things like Mesos and the things that DCOS are doing with, they open source, DCOS is open source. A lot of these universe components where you have built-in integrations to different services that you can embed very quickly into your application. I think that's going to also cause a huge uptake in the enterprise, because it's one less or a number of less service points they have to manage and integrate themselves, because it's already integrated in part of some type of a package that you can leverage. What's nice about something like that is you're not forced to use all the services that are available. It's just it's kind of like a shopping cart of common services that are available to consume if you choose to. I think those two things, in my mind, are really going to help drive even greater adoption in the coming year.
Let's take a quick break and get back to the show. Thanks to Cisco for sponsoring this episode of the new Stack Analysts. Cisco is an active participant in the cloud-native ecosystem and its development. Check out Mantle.io, the open source microservices framework developed by Cisco and the open source community. That's Mantle.io, MANTL.io.
Lawrence, have you been seeing anything in the regard of enterprise adoption?
In terms of enterprise adoption,
Yeah.
what I saw earlier in the year is that people who said they were going to start using it in production, going from trials to actually using it in production, about 2/3 of them have done that. So that's real. I haven't seen a lot of new data about if there's going to be a brand new set of people moving containers into production. And what I've seen right now is that a lot of what's in production are cloud native applications that were built recently. they're not necessarily legacy applications that have been re-platformed or just lifted, and that a lot of what is being run now in production is small scale. So a lot of, let's say, the benefits of using Mesos or Nomad as an orchestrator is because they're able to handle large scale deployments. But for now, there's not a lot of them. So that's one of the issues with the adoption of those other competitive type of products and offerings.
Well, imagine though that if you have an enterprise system and it's running okay, then saving money, well, it may be a cost of, when you talk about hardware licensing, but it's on the whole, it's probably not a huge priority, I guess, to shift those platforms. But but are you seeing that with new projects? Then that is the way that there is that a containerized, maybe even microservice-based approach does seem to be the way people are heading.
That's the preference people have. There's going to be reasons why you don't want to use a microservices approach for specific type of applications, but that's what people's first option is. And the other thing I would say is that gradually over time, as people pick new tools in their product development pipeline, software development pipeline, they are trying to pick tools that will be able to integrate with lots of different orchestration tools. So that, for example, if you are deciding that you actually need a continuous, something that's just not open source Jenkins for continuous integration, you're going to be looking to buy a system that can scale out. I think that Alex was using a term, a scale out architecture the other day with me, in terms of you want to be, when you're making a decision to get a new piece of the software, you're going to want to make sure that it's going to be able to integrate with everything, and that's going to include being able to deploy containers.
I think my experience in producing the container ecosystem series sort of is reflecting a lot of what Lawrence is saying. And this is, again, sort of subjective at a conversation level, but it sure does seem like, as this book series has gone on, is that we do less convincing people that containers are going to be big and more actually talking about the issues that are helping them use containers. It's sort of like, and I don't want to necessarily suggest that we've normalized the language, but it's just container usage is on the table, it seems, for people now. It's, as Lawrence is saying, it's kind of being baked into these solutions. It just feels like another one of these default approaches now. And it's very, actually, I guess not surprising to me, because when we started out this series, we had to rely heavy on language that said, hey, this is going to be how people are doing it. And I just think more and more that we are seeing that that is the case. And it's interesting to me because we have this ecosystem that has just so many products in it. And when Ken mentioned the kind of business value driving the explosion of open source solutions around containers, that just seems very much reflected in the work we've done. Just an avalanche of products, I think, that are available to people now. They're either container based or specifically meant for containers, or some major addition to a product that's meant to gear towards containers. And so it seems to like all these pieces are coming together to support the central premise that not only are containers necessary, but they're going to help achieve maybe this change in delivery and how things are done.
I mean, just to add one more thing to all this, what surprised me a lot this year has been sort of the quick adoption of some of the larger public cloud providers, right? Like Amazon and Microsoft and IBM supporting containers. But then, also the platform as a service companies are trying to get their hands on to the container platforms as well, right? And saying that, Foundry or Pivotal and OpenShift and Apprenda, and, you can go down the list of all the past providers out there. They're all trying to be more container and cloud native centric in the last 6 months, which is interesting to see. large groups of companies moving down this path so quickly.
So I'd
Not
like
to sound too contrarian about all of this.
Oh, not you, Scott.
No, never to be tremendously contrarian. I was speaking last week with a low executive level fellow with a major content delivery network, somebody who is in the job of devising systems that deliver workloads more expeditiously to major enterprises. And I asked him how the experience of Netflix and microservices has changed his outlook as with regard to the way he does his job. Has microservices and what many of these other players are doing affected his view of CDN architecture and how he might want to change that going forward? And his response was, what? And I said, microservices, the model where you have very, very small services distributed in a highly complex parallel architecture. And he said, interesting. This have you read an article on this? And I said, well, I've written several. Might want to check out the new stack.io. But this, he said, this could be something. And what he demonstrated for me again, and I keep falling into this, is there is a huge segment of what we call the enterprise for whom what we are doing right now has yet to make a dent.
Yep.
And these people are in services that you would think that containers would be addressing. Video and audio multimedia delivery is one of them. Healthcare is another. Banking and finance is another. Huge industry segments. It's unbelievable how government services, especially federal government services, are leading the way in adopting these new architectures, are setting the standards for embracing containerization, whereas commercial enterprises are falling behind. And in a way, it's kind of crazy. I've said before that enterprises will take the advice of whatever their consultant of choice tells them about the future, but they may defer that advice for a few years. And you've got consultants who are coming in and they're working with Microsoft and Amazon, and for 5 years or more, they've been advising enterprises, well, virtualization is really the path forward for you. You've got to be able to explore improving your efficiency. And the enterprise's response is, yeah, we kind of agree with that, but we have to wait and let our current systems amortize a little more, and then we'll be moving on to, adopting this vSphere thing that you're talking about. Well, to borrow a phrase from my friend Joe Biden, the window for adopting that is closing. We're moving out of that phase. And here these institutions are 2 or 3 generations behind. And the time is fading for them to adopt the first level of containerization. Now it's incumbent upon them to start thinking about containerization, workload optimization, microservices, and these things that are way ahead of them. It's like asking them to put down their Atari 2600s and pick up a multiply massive online role-playing game and say, okay, go for it. Here it is.
You're not being fair.
So what's the kind of the consensus there? Then are you what the question here then would be? You are seeing then that there's a lot of untouched. There's a lot of people who really haven't even touched microservices. There's different levels of kind of adoption, and there's kind of a missed opportunity here for it. Ken, what do you think about that?
I thought about a couple of things as you were describing, that scenario that you were referring to, and I think, in my view, that there's a couple of interesting points here, right? One is that I think we would do a disservice in this industry if we tried to say that every application should become containerized and following a microservices architecture. I don't think that's the goal. If you look, I don't know the current numbers, but as of 3 or 4 years ago, it was only 80% of the enterprise workloads were virtualized. and only about 10% of those workloads are in the public cloud, right? And I know that number is going up, but it's not, it's not 100% in the cloud, right? A lot of companies are skipping virtualization and we're trying to go straight to cloud. That's where OpenStack got a lot of early day adoption, right? And now the containers are out. There's a lot of customers I talk to that are skipping OpenStack and going straight to microservices, right? Including a large cable company that's not the same one Scott was talking to, but another one that Cisco works with very closely. They're completely skipping OpenStack in several parts of their cable application area and going straight to microservices. They're also a big OpenStack shop and will have OpenStack for some of the infrastructure use cases, but their view is why add another layer of virtualization to the applications when they're very sensitive to latency and any kind of additional processing, so they can just go some of their video application and go straight to a container architecture. And so I think you're going to see, I know we talked about how fast this Kubernetes has grown, and we started talking about how fast this environment is going, and that's true. But as fast as we say it's moving, it's still very, very early days of containers. And I think we need to keep that in mind as we talk in these conversations, that we're at the edge of the sphere there, right? And it moves very quickly, and that window for things like virtualization may be closing, to Scott's point. But there's still a ton of virtualized services being deployed. There's still a lot of whether you call it the opposite of still virtualization, but KVM, doing like OpenStack and other types of application or virtualization platforms are being deployed. Things like even Cloud Foundry, I would put into that bucket of it can run without any sort of containerization at all. It's just a platform view versus infrastructure view. But I think to answer your question, Alex, I think that to me there's couple of different camps, and I would say that the first camp is sort of the guys that are on the bleeding edge. They want to adopt the new technology, and they've sort of been the first ones to jump into this. You then sort of have the guys that are looking at their business and saying, okay, new applications are going to go to this model, but our existing applications are going to leave off to the side. That's kind of the second camp. And then the third camp are sort of saying, this container stuff sounds cool, but I have a business to run. I don't have time to refactor my application to 12 factors. I barely have time to just keep the thing, the lights on right now. I'll get to that later, but right now I just got to keep my business running. And then you have the third camp, which is the camp Scott defined, which is, these are the guys that are like, I've done it this way for 20 years. I'm not going to change. And I don't care what two new technologies are out there. I'll look at that when I have time. And for that camp, that's sort of like the 10 to 20% that haven't virtualized yet. You're never gonna get a mainframe to run inside a new Kubernetes orchestrated model, right? The mainframes still exist. They're still going to do what they've always done, and they're not going to refactor that application to do something differently.
So, one of the things I get out of this is really where we're moving into 2017, and and one of the the major themes we're looking at now is not just building out these scale out architectures, but how do you manage them? How do you maintain them? And that's, to me, seems like a big question to ask of people who are new to this stuff, right? Who are needing to find ways to to make their way through this. But I think even the bigger theme is in the practices that you see with companies who are developing their own internal architectures to be able to then turn them inside out almost, right? So they can have a common API lifecycle management process. So if they're using internal APIs, they can basically kind of turn the endpoint, make the endpoints public, and start offering a service that they can that their customers can use. And that's that's a new world, I think, for a lot of people. And it seems that there's a lot of questions that need to be answered in terms of your architectural choices, right? That you need to make internally. And that speaks to, I think, still very much of the immaturity of the Docker container ecosystem, because there's going to need to be almost kind of like these very, simple direct connections for, pushing apps into marketplaces and, and using microservices in the context of an API lifecycle management, environment. And, one of the things I think, and Lawrence was just bringing this up and kind of, in a private conversation that, we're starting to see other things happen too, like, the trends around bare metal, right? And, and virtualized infrastructure. Lawrence, what are your thoughts on that? What you're seeing kind of emerge in this past year and how that kind of reflects in kind of this move towards scale-out architecture?
Well, first, I'll say that I know that Kubernetes is creating a SIG based off of working with bare metal, that there's a few specific use cases where bare metal makes sense. And I am right now opening up a document that has a chart, and it says it's from IHS Market, and basically it says that right now 4% of data center servers are containerized. So I'm assuming that's bare metal, and they're assuming that's going to double in the next 16 months. So I don't know as much about it as I would like. That's why we have Ken here to explain the benefits and basically are people bypassing these certain platforms and operating systems to go straight to the source.
Yeah, they definitely are. The cable company I mentioned before, that's exactly what they're doing, is they're bypassing any other layers, just go straight Kubernetes on bare metal. And the primary driver was around performance and getting rid of any of the overhead that you get with other sort of use cases. Because in their use case, latency does kill video service. So their view was, we got to get off anything else other than bare metal. And the interesting thing with that is that this isn't the bare metal that a lot of people listening to this may think it is, right? It's not just a, an x86 generic server, right? Most of these servers have GPUs in them, or they have, some of the trusted computing capabilities from Intel with the TXT chipset, right? So they're able to take advantage of offloading some processing and take advantage of some of the security capabilities that are built into the more advanced server architectures. And they're able to take advantage of some of the hyperscale capabilities that are being built into bare metal today to really expand across multiple physical servers as if it's a single physical server. And so I think those three components, coupled with Kubernetes for scheduling and orchestrating, I think you can now kind of see a full picture of why bare metal is of interest to the community, because it's not just a server sitting there doing nothing. It's a server that has a lot of intelligence, a lot of performance,
right.
and a lot of scalability that's going to make those applications, behave as if they were sitting on a physical environment without any other layer around it.
Ken, in light of what you said about GPUs, would it be to Cisco's benefit? Would it be to Cisco's customers' benefit if Intel and Xilinx and folks in that genre were to endow their FPGAs with ways to accelerate Kubernetes code the way they're accelerating other types of open source codes, for instance, for artificial intelligence?
I cannot confirm or deny the discussions we're having with those companies. But yes, it would be very helpful for that to happen.
Yes, Ken, this is Bob Woodward with Carl Bernstein. We're with the Washington Post.
Great. We're coming up to the top of the hour, and I just want to see if there's Joab, if you have any last question for Ken.
No, I'm trying to think of where. Well, yeah, actually, I do. Last week we saw that Docker had updated the Docker data center, and one of the inclusions with this new service is the orchestration engine, formerly Swarm. Many people still know it as Swarm, but what I'm kind of curious as to the role of Docker itself. This seems like Docker itself is filling out a full portfolio. I would imagine it would be possible for many organizations to just become what we used to call a Microsoft shop. Now we might just see what you might call a Docker shop. Is that kind of the path forward for Docker itself? Is there going to be a split between Docker users and the more heavyweight Kubernetes users, or I guess what's Docker's role in the future?
Yes, I think that's a very important question that I know, in my role at Cisco and my role in the CNCF, I'm trying to understand that a little bit better, because I think a split in that community would be very bad, right? I do agree with you that it appears that Docker is trying to become the next VMware. I think they're trying to be more like VMware than like Microsoft, as you described them as. But I think they want to kind of own that next, transformation in the enterprise towards containers. And they're trying to provide all of the tooling and all of the networking and all of the orchestration needed within just the Docker ecosystem. That to me screams of lock-in and I'm building a wall, which I'm trying to avoid. And so my advice to Docker and my advice to the community has been, let's not allow that to occur in a way that creates a wall, right? We're not going to stop Docker from integrating their services together, which I am not trying to say they shouldn't do, but I think it needs to work as well with Kubernetes and as well with Mesos as it does with Docker Swarm. And
so I'm kind of curious. So for the mid-sized business, it strikes me as that, everything that Docker is offering is perfectly fine. But what you're saying is, should the mid-sized business grow to be really successful, then what you want is a path towards Kubernetes.
Right.
That would make it easy to,
Exactly. Yeah, there needs to be integration points that allow the users the choice of where they want to go today and in the future. I think if you get too locked into one way of doing things, and it, even a company as big as Cisco, right? We have integration points with all of our competitors because our customers demanded that of us years ago, right? We're not going to be the only router on the block. And so our routers connect and interoperate with every router in the industry. And there's a reason for that. And that is what I think we want to try to do with the cloud native work as well, is make sure that you may have a better solution and you may have a market that you can create around your solution, but you have to interoperate with other solutions. But companies are not going to buy, I don't think companies will buy a vendor-only lock-in model today. I know they did in the past. I think just the amount of complaints I hear every day from my enterprise customers, they really don't want to be locked in anymore.
Well, good. Well, anything else from the editorial crew here? We're coming up to the top of the hour. Ben, any last thoughts? Any question? Anything from?
Sure. So, Ken just mentioned lock-in there. Basically, since we're looking at a retrospective of sort of the container ecosystem over the last year, a lot has happened with the CNCF in the last year between accepting Kubernetes and sort of rapidly growing that portfolio. I'm kind of curious to hear from you, Ken. You're in a good position to talk about this. What the role of foundations like CNCF is going to be, and maybe even the next year of the container ecosystem, because it seems like it is certainly growing very actively. And I'm curious what you think the future looks like for that.
Yeah, I think the role of the foundation is sort of a couple of main points. One point is we want to try to help shepherd projects into this community, right, and into this ecosystem, and give them the right guidelines and the right guardrails, if you will, to sort of grow and become a cloud native project. And that doesn't mean more like a dictatorship or we're creating requirements or standards around this. We're just sort of, we spent the last year kind of defining processes and what it means to be an incubation project versus, a full-fledged cloud native project versus, a growing project. And so we've done a lot of work around how do we kind of help this community and this ecosystem grow. And we also spend a lot of time with the community projects, working with them and helping them, with documentation, helping them with testing. We have a huge test bed that Intel and SuperNAP have provided to our project. So we have a great environment to kind of help test and do some things that you don't typically have the ability to do in an open source project, because you don't have the ability to do scale testing and performance type of testing, which you can get in this large Intel environment that we have. So that's one piece. The second piece, which I think is probably just as important, is to the point you guys have made a couple of times in our conversation today. There's cloud native meant so much before, in the end of 2015, it meant so many different things. At the end of 2016, I think the CNCF has really put a nice nomenclature around what cloud native means, what types of components belong in the cloud native architecture. And then with the latest work with the landscape that we announced at the conference 2 weeks ago, you now have a nice little landscape of companies that sit within those different components that make up a cloud native architecture. And so as you look at going into 2017, our goal is to take a lot of those projects that you see in that landscape and bring them into the cloud native foundation in a way that allows us to help them incubate, help them grow into full-fledged, major cloud native projects in the future. And that integration piece I talked about is a big part of our charter. Let's make sure that these things can integrate. We brought in Kubernetes first, but believe me, we have talked with Mesos, and we have talked with Docker, and we have talked with, Cloud Foundry. We're talking with OpenShift, right? We're trying to make it we're trying to bring in as many different, what you might call competing projects, because in our mind, that makes a good foundation when you have choice and you have interoperability between those choices.
I know Scott has one last question.
And I'll try to make it quick. I've heard the argument made before that the IETF helped the internet to succeed by helping people to care less and less about packets. And that argument applied to the container ecosystem would be that if the CNCF's efforts are successful, people will end up caring less and less about the container and more about the workload. Do you agree?
I agree. Yeah, that's definitely a big part of what we're trying to accomplish in the CNCF, and it's more around that microservices architecture and less about the orchestration and the containers.
Great. Well, Ken, thank you so much for taking some time to talk with us. You got the attention of the full editorial team, and and I think these guys could probably go another 2 hours asking you questions.
It was fun.
Only two?
We can do this again.
Well, Scott says only two. Okay.
No, it's always fun. Thanks, guys, for all your time and great questions.
Thank you, Ken. Good to be with you today.
Well, thank you very much, Ken, and we'll talk to you soon. It's been another show of the New Stack Analysts. We'll see you all soon. Thanks. Bye-bye. Thanks to Cisco for sponsoring this episode of the New Stack Analysts. Cisco is an active participant in the cloud-native ecosystem and its development. Check out mantle.io, the open-source microservices framework developed by Cisco and the open-source community. That's mantle.io, MANTL.io.